All right, so we can see that it's going up, it's going up, it's going up, it's getting closer, it's almost up to 255, and it started over. We can see that when it gets up to there, we didn't tell it to start over. What we said is go up to the next number. It tried to go up to the next number, but it can't hold a number bigger than this. And so what it does is it just goes ahead and it starts over. It just has to roll over and do all that. So what if we did an integer? Well, an integer goes up to 32,000. We'd be here all day. Well, not all day. We'd be here a while watching it count up. So what I think I'm going to do is I'm going to do something a little bit different. I'm going to say, instead of counting up by 1, I want our x to add, let's do 500 every single time. So it should be 0, then 500, then 1,000, and it should go through that. Upload the code. Oh, I forgot to turn auto scroll on. Whoa, something weird happened there. Let's take a look at it. So we start off at 0 and we count up. We get to just over 32,000. And then it rolls around to negative 32, 536. Well, that's 500 more than this number, kind of. It had to roll around. It had to start back at the other end of my spectrum. Remember, the integer has a negative 32,000 and something. It can go up to a positive 32,000 and something. When it got too big, it had to jump to the opposite end of the spectrum, the negative 32,000, and start counting up from there. And so that's why it keeps counting up and keep counting up. And eventually, we get to our positives again, and then we jump to our negatives again, and it's just going to keep doing that. It's cycling through our numbers. What would happen if I made this unsigned? Unsigned means we're going to get rid of these negatives, and I should be able to count up a little higher as well. I keep forgetting to turn auto scroll on. All right, so now we're counting up to about twice that. And if we look at what the values of an unsigned integer are, they go from 0 up to about 65,000. So there we go. And then it has to start over. So this is an interesting way just to kind of see what's going on. I can put a number in, and I can just keep putting these values in, changing them to see what's going to happen. I could do this for all different types. Arduino does do some weird things, and the way that memory works, you might not always get what you expect, but it's an interesting way to understand data types a little bit more. So if, and one interesting thing to this would be if I put a delay in, and I wanted to, let's say, put a delay of X in. I'm going to change my print. I'm just going to print a word. I'm going to put the word hey. And what I'm going to do is I'm going to change this to a byte. Byte X, and I'm going to put the number, let's see, what would be a good number? Let's try 1,000. Well, normally what we would do, and we've done this sometimes, is we're going to make a variable that's going to hold our delay. But what I've done is I put the wrong number in here. If I want to put the number 1,000 in here, I should have chose a larger data type. This is too small. This can only hold a variable that is up to 255. So what's going to happen? Well, we know what's going to happen. It's going to have to start over counting. I try to put too big of a number in, it's going to get up to 255, and it's going to have to start back at 0 and count up another 255, go back, and it's going to keep doing this. So let's upload this, and see how long the delay actually is. It's very quick. And so sometimes things aren't going to work out very well if we choose the wrong data type. It's not going to work the way we think because the data type isn't the right thing. We have to be very, we have to use the right thing for our data type. We can't just throw something out there and hope that it works. We have to know why we're putting the data type in. We have to make sure that it's the right value that we're plugging into it so that things work appropriately.